Good morning. This is Ms. Billerbeck, and we are going to talk about 7.4, factoring polynomials. So first, when we're factoring, we want to find the greatest common factor of the terms of each polynomial. So let's break this down into a little bit. So we have into prime factors. So we have 3 times 5 times x plus, and this would be 2 times 3 times 3. So we scan, we look for something that's the same. So we see, oh, they have a 3 here and a 3 here. So the greatest common factor is 3. So if we were going to use that, then we would take the greatest common factor out and we'd have 5x squared left over, and then plus 2 times 3 is 6. So that's how we factor out these terms, factoring out the greatest common factor. So this one we have -1 times 2 times 3 times 3, and then we have 4 y's. Well, say just y plus 2 times 3 y, and then, oh boy, we have 2 times 3 times, well, that's 2 times 2 times 2 times 3. Sorry, I ran out of room there. And then y. Okay, so if we look at what they have, this one has a 3, that one has a 3, that has a 3. Let me rewrite this so it looks the same. So we have -1, I will have to do parentheses around that. So that's 2 times 3 times 3. All right, so we have a 3 in common, we have a 3 in common, and a 3 in common. Okay, we check, oh, we have a 2 in common, 2 in common, 2 in common, and then this has 2 y's. We can take 2 y's from here and 2 y's here. So our greatest common factor then is going to be 6y squared. So we can pull all of that out. So if we were to factor this polynomial, we would write 6y squared, and what's left is -1 times 3 times y squared. So that's -3y squared. And then this one, we took that out, we just have plus y left over, and then we have plus 4. So that's what that would look like when it's factored. Okay, so double check, 6 times y, 6 times -3 is 18, y squared times y squared is y to the 4th, 6y squared times y is 6y cubed, and 6 times 4 is 24y squared. All right, so we do the same thing here. We see there's no coefficient here, so we are going to be taking out a number, but we do see that they all have an x. So we have x plus 5 times x minus 2 times 11x. So we can pull the x out. That gives us x, and then what's left over is x squared, 2x is here, plus 5x, and then minus 22. So our greatest common factor here was x, and that's what it would look like factored. All right, so when we look at this one, we have -2 times 2 times 2 times 2. And then there's 6 y's, y, plus, and then this is 2 times 2 times 7, y, minus 2 times 2 times 5, y. All right, so we see there's 3 y's here and 3 y's here. So those are a common factor. This has 2 2's, that has 2 2's, and that has 2 2's. So we can take those 2's out. All right, so we write, so our greatest common factor here then is 2 times 2 is 4, and then we have a y cubed in common. So if we were to factor that, we have 4y cubed. What's left over is negative 2 times 2 is negative 4. There's 3 y's left over, y cubed. This one has a 7y. And then this one just has minus 5. So we can quickly check with this then. So 4 times negative 4 is negative 16, y cubed times y cubed is y6. 4 times 7 is 28, y cubed times y is y to the 4th. 4 times negative 5 is negative 20, y cubed. All right, so that's how we do our factoring with greatest common factors. So let's try a real life problem. All right, so what expression would represent the photo arrangement in area in simplest factored form? Okay, so we know that this area here is x squared. So we have x squared plus x squared. So 1x squared plus another x squared. And then this one is 2 times x. And we have 1, 2, 3, 4 of those. So let's multiply by 4. Okay, so if we put this together, we have 2x squared plus 8x. Now we look for the greatest common factor and we see, well, they have 2. So I have 2xx plus 2 times 2 times 2 times x. So we have a 2x in each one that we can pull out. So this would give us 2x, and then we just have x plus 4. Okay, so that would be what the area of all these photos would be 2x plus x plus 4. So what that suggests is it might be better to arrange this. I'll do this on a very small scale. So it might make more sense if we arranged it like this, where we had x, 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 and then this was 2 and 2. So that would be a more practical use of your photo paper. So if we tried to print out our photos like that, it might not fit on one piece of photo paper. Okay, well, that's it for this lesson. Have a wonderful day. Bye-bye.